greatest common factor is the highest number that divides into two or more numbers evenly. The lowest common multiple is the lowest number that two or more numbers divide into evenly. I used to have no clue how to figure those two out until I learned about prime factorization, finding the prime numbers that go into a certain number. When you know that, it's easy. Let me show you.
Hi class, it's Mr. Robinson here, and we're going to be talking about how to find the greatest common factor and how to find the lowest common multiple. And we're going to use prime factorization to do it. We've got number lesson number 2, and we're going to call this applications of prime factors. Now I've got two numbers here, 48 and 72, and I've made the prime factorization. I found all the prime numbers. So the prime numbers of 48 are right here. The prime numbers of 72 are all right here. All right, now if you need to know how to find the prime factorization, you got to go to another lesson. You can go to number lesson number 1, and I go through that. But here we're going to be talking about the greatest common factor. We have to know, though, that with 48, we could say that it's 2 times 2 times 2 times 2 times 3. We could also say it's 2 to the 4 times 3. Same with 72. 72 is 2 times 2 times 2 times 3 times 3, but we could also call it 2 to the 3rd times 3 squared. Now let's talk greatest common factor. Now if you were asked to find the greatest common factor of 8, 16, and 20, that wouldn't be a huge issue. You'd probably just say, okay, well, it's 4. So 4 goes into all of these numbers, all right? And it's the greatest one. We could say 2, but it's not the greatest common factor. We could also take a look at 15, 25, and 35, and we'd say, okay, well, 5 goes into all of these, or how about 2 is the greatest common factor going into both of these. Some might say, oh, well, maybe 4 does. Yeah, 4 goes into 20, but 4 does not go into 18, so it can't be 4. And if you have 36 and 54, you might have to do some calculations and say, well, 2 go into both of them, and I think 9 go into both of them, but hey, I think 18. Yeah, 18 goes into each of them. So that is the greatest common factor for 36 and 54. Now, if we wanted to go and talk about finding the greatest common factor of 48 and 72, these numbers are a little bit bigger, and it gets a little bit more complicated than just searching my brain to figure them out. But we have this prime factorization, and that's going to help us out. So really, to determine the greatest common factor of those numbers, we find the product of each prime factor, including repeats, which is common to each prime factorization. Let's make that real easy. If I see a 2 here, I circle that 2 there. I see a 2 here, and I got a 2 there. I got this 2 here, and I got this 2 there. I see this 2, but there's no friend over here, so I'm not going to circle that one. I see this 3, and there is one over here. I look at this 3, but there's not another 3 over here. Now I take this 2, okay, this 2, and this 3. The ones that are common to both of them, I multiply them together. 2 times 2 times 2 is 8 times 3 is 24, and that is my greatest common factor. And that is it. It is not difficult. It's very easy. You find the prime factorization, you find which is common to each, and the ones that aren't common, you can't multiply them. You just take one of the sets and multiply them together. Don't multiply that set and that set together. You just take one. All right, so I want you to go through a class exercise here. We've got 2 questions, 90 and 225, and we also got 154 and 198. I want you to press pause and find the prime factorization and then the greatest common factor for each number. Press pause now. Now I've got the prime factorization for each of these numbers, and I see that they do have some numbers in common. I see a 3 over here for 90. I've got a 3 over here for 225. I also see another 3, okay? But I don't see a friend for this 2 here. I'm not going to touch that. I do see as well a 5 over here and a 5 over here. So the greatest common factor is going to be 3 times 3 times 5. And so that is 45. Over here with 154 and 198, I see a couple of common things. I see this 2 is common. I also see this 11 is common. That gives me 2 times 11. The greatest common factor is 22. Now I use tree diagrams to do this one. I'm going to do this next one a little bit differently. Now I want you to try to take these three numbers, whether it's 245, 315, and 770, or these four numbers here, 171, 285, 399, and 1140. I want you to find the prime factorization, and then I need you to find the greatest common factor for each. Try that. Press pause now. Now I used a division table to find these prime factorizations. I have over here a 5, 7, and a 7. I've got a 5 and a 7 over here, and I've got a 5 and a 7 over here. That is all that's common, so this 7 doesn't have a friend. 5 times 7 is 35. The GCF for those three numbers is 35. Over here for these four numbers, I went through and I found what is common, and I noticed that all we have is a 3 and a 19 that are common throughout. And so when we have our 3 and our 19, then we know that the GCF would be 3 times 19, and that would be 57. Here are my 3's in each, and here are my 19's in each. And that's the GCF. Now, the lowest common multiple, we use the prime factorization again. In this case, though, we're going to take factors from one of them. So we take all the factors from one number and then multiply by any additional factors in the other numbers that aren't already repeated. So if you have something like 10, 12, and 14, let's take all the numbers of 10, 2 times 5, and we already have a 2 here, but we actually have another 2, and we've got a 3 that isn't here, so we're going to take those two. We've got that 2, which is common, but this 7 is not common. We're going to take that too. So you can see that we're going to get a higher number. So now that we have that, we've got 2 times 5 times 2 times 3 times 7, and that is going to give us 420. So the LCM, the lowest common multiple of 10, 12, and 14 is 420. All right? Now, I've got this class exercise 5 here. I want you to use prime factorization to determine the lowest common multiple, the lowest number that both of these numbers go into. Press pause and do it now. So I did the prime factorization for each of these numbers, and for 15 and 35, 15 is just 3 times 5, and 35 is 5 times 7, and those are all the prime numbers here. So the lowest common multiple takes this 3 and this 5. We'll start with that. We see that the 5 is common, so we're just going to take this 7 here. We multiply it together and we get 105. Now I wanted to just show you that, yeah, it works this long way. You could take the 15 and find all the multiples, 15, 30, 45. You'd go all the way up to, let's say, 120 or 135, and then you take the 35, you do the same thing, 35, 70, 105, 140, 175. And then you find what is common, right? The common multiple, the lowest one. And I see that 105 is the lowest common multiple. So it works. It really does work. Letter B, we've got 126, 441. I found the prime factorization here. I've written them out here. Okay, so we've got 126, you've got a 2, a 3, a 3, and a 7. 441, we've got a 3, a 3, a 7, and a 7. So let's find what's common. We'll take 1 first. So let's take the 126. And then we see that, okay, I've got a 3 and I got a 3. Well, they're already there. So those are common. I'm not going to include those. But I've got this 7 and this 7 as well. So I do have this one, but this extra one I've got to include. So now I take the 2, the 3, the 7, and then this extra 7. I get 882. That's the lowest common multiple. And then finally with these three numbers here, 22, 154, and 198. With 22, you got 2 and 11. Okay, let's start with the number that has the most. So let's start with 2, 3, 3, and 11. Okay, so we just have to add this 7 because this is a 2 and 11 and this is a 2 and 11. So just add the 7. We multiply all that together and that's going to equal 1,386. Now the interesting thing about this is that we can talk about perfect squares and perfect cubes, and we can figure out if something is a perfect square or a perfect cube by looking at the prime factorization. Okay, so what I want you to do is to complete the prime factorization for these perfect squares, and you're going to notice something special about prime factorization for perfect squares. Press pause now. Now I've completed the prime factorization for all of these perfect squares, and I hope that you notice something. We've got 9 and it's 3 times 3. We've got 36 and it's 2 times 2 and 3 times 3. We got 49 and it's 7 times 7. Seems like everybody's got a friend here. They're all pairing up. Look at this. We've got 64, but look at the pairs. We've got 2 times 2, 2 times 2, and 2 times 2. All right? We take one of these numbers, okay, and that's the square root. All right, so we've got a pair of 3s, we just take the 3, and that's the square root. We've got a pair of 2s, so we take a 2. We've got a pair of 3s, we take a 3. 2 times 3 is 6, and that's the square root of 36. We've got 2 7s, so 1 is the square root of 49. And then we've got 3 sets of 2, so we're going to multiply those 3 2's together, and we get 8, and that's the square root of 64. So you can use this prime factorization for other things like square roots. And if you find that the prime factorization of a number does not result in pairs, then that's not a perfect square. All right? So try this. This is an advanced exercise, but consider this number and see if it is actually a perfect square. Give it a go. Press pause now. Now I've got the prime factorization for the number 44,100, and you could use a calculator to find the square root, but we're going to just use the prime factorization to see that when we factor it out, we've got a 2 here and a 5 here and so on. Let's take a look if we have pairs. Well, we've got these 2's are pairs, these 5's are pairs, we've got a pair of 3's and a pair of 7's. So everybody's got a friend. If everybody's got a friend, we've got a perfect square. So all we need to do is to take one of each of these, so 1 2, 1 5, 1 3, 1 7, multiply it together, and our square root is 210. All right? So now we can do that with these numbers. I have done it already. If it was 1,225, yeah, that is a perfect square. If it's 3,042, well, we've got a 2 here all by itself. So that is not a perfect square. This also works out with perfect cubes, but the difference is if you take these and take a look at these, if you take a look at 1, well, 1 could be 1 times 1 times 1. 8 is 2 times 2 times 2. 27 is 3 times 3 times 3. So in all of these, it's not that they have one friend, but they've got 2 friends. We have 3 of them that makes that. And so when we find the prime factorization for these numbers, all we have to do is see if there are 3 of them. And if there are 3 of them, then it's going to work. Okay, so for 216, we've got 1, 2, 3 3's, and we've got 1, 2, 3 2's. And so that works. Also for 3,375, we got 3 5's and 3 3's. And if we wanted to find out what the cube root is, we just take one of those 3's and one of those 5's, multiply it together, and the cube root is 15. All right? And that is the lesson. I hope it's easy for you. Prime factorization makes the difference. Thanks for watching.